Here we have the infinite series of sine squared of n divided by 2 to the n, and we want to show that this series converges by using the direct comparison test. And to use the direct comparison test, we have to come up with a series b sub n, and then show two things. Series a sub n, which is the given series, is less than or equal to the series b sub n. And then we also need to show that the series b sub n converges. Then we can say that the given series converges. So we can let a sub n be the given sequence here. And then we can let b sub n be 1 over 2 to the n. And the reason for that is because of this. Sine squared is always going to be, sine squared of n is always going to be less than or equal to 1. Because recall that the sine of any angle is between -1 and 1. And so that's why we choose 1 over 2 to the n. And so we can see that this series right here is less than or equal to this. Because sine squared of n is always going to be less than or equal to n. Less than or equal to 1. And so we have just shown that this series is less than or equal to the series b sub n. So we have shown the first part, and now we need to show that the series b sub n converges. Now this series, this is the 1 over 2 to the n. This is the same as 1/2 to the n. And this is a geometric series. With common ratio r equal to 1/2. And since we have r is between -1 and 1, this series converges by geometric series test. So that's what the geometric series test says. If the common ratio is between -1 and 1, then the series converges. And therefore, by direct comparison test, this series converges. And so once again, to use the direct comparison test, we have to come up with a series b sub n, and then we have to show that the series a sub n, which is the given series, is less than the series b sub n. And we have to show also that the series b sub n converges. And over here we've shown two things. That this series, the given series, is less than the series b sub n, And then here we've shown that the series B sub n converges. And therefore we can say that the given series converges by direct comparison test.